Alright, 6A. Find all the zeros and sketch the graph. And our given information is that 2 is a double root of the function. What that means is 2 is a solution of multiplicity 2. Okay, well, what does that mean? Well, that means that using the linear factorization theorem, x minus 2 is a factor if 2 is a solution, if 2 is a root. And it being a double root, it being a solution of multiplicity 2, means that it is a factor twice. It has a multiplicity of 2. So I can, if I wanted to, I could expand that and get x squared minus 4x plus 4 and do long division. But long division's kind of poopy. And so I like to do synthetic division, which means we will be dividing by the solution to x minus 2, which is 2. And we list our coefficients: negative 1 x to the fourth, 6x cubed, negative 9x squared, negative 4x, and positive 12. So the very first step in synthetic division is to pull down that first coefficient, that negative 1. And now we multiply. 2 times negative 1 is negative 2. And now we add. 6 plus negative 2 is 4. And now we multiply again. We're always multiplying by that. So 2 times 4 is 8. Negative 9 plus 8 is negative 1. 2 times negative 1 is negative 2. Negative 4 minus 2 is negative 6. And 2 times negative 6 is negative 12. And we're happy because 12 minus 12 is 0. And that is our remainder. Now, this represents the polynomial negative x cubed plus 4x squared plus lies, lies, so many lies, so many lies. Wait, how many lies? Let's go back. 4x squared, boom, minus x minus 6. There you go. It is building up in powers of x as you move to the left. But we don't actually even care about that at this point because we know that 2 was a double root, which means I can now divide this again. So this right here is representing dividing by x minus 2. And we're going to do it again. We want to again divide by the factor of x minus 2 because we know it is a multiplicity 2 solution. So divide it again. Same process. Drop that negative 1 down. Negative 1 times 2 is negative 2. 4 minus 2 is 2. 2 times 2 is 4. Negative 1 plus 4 is 3. And 2 times 3 is 6. And again, we are happy because negative 6 plus 6 is 0, which represents our remainder, which means, yes, x minus 2 was a double root. So this gives me negative x squared plus 2x plus 3, which is gross, so we factor out the negative to get x squared minus 2x minus 3, which is less gross because we can factor this as x minus 3 and x plus 1. So maybe you're sitting there and you're like, oh, sweet, so my answer is that. No, you're forgetting that we've divided by x minus 2 twice. And that is still a factor. Do not forget to write those factors in the end. We were calling this y, so there is y now completely factored. And now we can go through and figure out what we want to know about this. Things we want to know is that the leading coefficient is negative. What else do we want to know? We want to know that the degree of this function is a 1, 2, 3, 4th degree function, right? 2 powers of x, 1 power of x, 1 power of x, adding them together. 2 plus 1 plus 1 is 4. If the leading coefficient is negative and the degree is 4, my end behavior will be down and down, like a negative x squared graph. All right, well, what else do we need to know? Let's identify our y-intercept. Hey, look, it's right there at positive 12. That's nice to know. So my y-int is at 0, 12. What else? I know my x-intercepts will occur when x is 3, when x is negative 1, and when x is 2. And I know that x equals 2 is special because that 0 will bounce. All the others will cross. And again, that is coming from the multiplicity of the zeros, right? Multiplicity 1, multiplicity 1, multiplicity 2 means it will bounce. All right, that's enough info. Let's sketch this little feller. And what do we get? X equals 3. 1, 2, 3. There's a 0. I will cross. X equals -1. There's a 0. I will cross. And x equals 2. There's a 0. I will bounce. My y-intercept is going to be up at 12. And I know I'm down, down. So cross 12. Bounce. Back up. Turn back down. Cross again. And I know that that point is 0, 12, and life's good.